Ew. Finally some videos, huh? Your teacher got way behind? Finally crawling out of the hole? Here we go. Vectors. Let's get into it. So we'd already discussed a little bit in class. Some of the stuff that we did was our component form of a vector, right? I made you draw some pictures, turn in, get some easy points. So you've already done the component form of the vector, but I thought, let's pull up the definition that the book has. You know what I mean? Making it kind of crazy. Trying to make it seem like it's more than it is. I mean, just look at all this. Like, what the hell? What is all this saying? And what's crazy is you already know. Oops. You already know all this shit. You already know all this. So, it's saying we're going from a point. I mean, like, I don't know, 3, 1. And then you're going to some other point. Maybe like 4, 2. Make it real freaking simple. And we're saying that the vector, our directed line segment, look at this thing, it's like this directed thing from P to Q is equal to our V vector, right? That thing's bolded. When you write it, you put a little hat on top of it or something. And all it's saying is the difference in it's the difference in your X values, comma, the difference in your freaking Y values. But isn't it crazy how tough we make it look? We make it look like it's something crazy. When really, we're just saying, hey, dude, we're just saying that our little V vector here is just, let me make sure there it is, there it is. And we're gonna be like, let's just go, since we're going to here, it's 4 minus that 3, right? And then we're gonna do the difference in our Y values, the 2 minus the 1. Oh wow, that was so freaking tough for 1, 1, saying that the X value goes up by 1 and the Y value goes up by 1. So our vector is telling us, hey, we're at 1, 1. It's telling us how we're moving. Vectors tell you your directions. Go 1 in the X value, positive. Then go 1 in the Y value. You know what I mean? Go east for 1 block, then go 1 north for 1 block. Same shit. Except it's like the crow that flies. It goes straight. And then underneath it, it talks about our magnitude, or the length of our vector V. And that's just the frickin' Pythagorean theorem. It's just the Pythagorean theorem. It's a squared plus b squared equals c squared. Just going to show you. A squared plus b squared equals c squared. Now, if you hit everything with a square root, what ends up happening? You get c is equal to the square root of a squared plus b squared. That's what that shit's saying. That's what it's saying. It's just it's the Pythagorean theorem. It's written differently. So let's look. Let's see for our example. We had our vector was 1, 1. So it's saying the length of this bad boy. Right? I don't want to take it out of 3, 1 and go up to 4, 2. I just want to do one of these and put it out of the origin. Because vectors can come out of wherever the hell you want to. It's just directions. And we've discussed already at the beginning of the course kind of what they meant. So there's a little frickin' vector. We want to know how long it is. Oh look, 1, 1, 1. Make a little frickin' right triangle out of it. What's going on? Pythagorean theorem. So we can say that the magnitude of our vector V is just going to be, right, see all this bullshit? We already solved for it up here. We already know the vector. So it's just 1 squared plus 1 squared, which is telling us we get the square root of 2. And that's how long the dang thing is. Bang. No biggie. No biggie. Component vectors, simple shit. You just got to get your practice with them, right? I bet that was the easiest 5-point you ever got on that little assignment. All right, now down at the end, let's just read the rest of it. Now, what's up? It's saying, if the magnitude is equal to 1, if the length is 1, let's start getting used to this idea. We're going to call that the unit vector. Okay? The unit vector is going to be a big thing we're going to end up using a little bit later. But there we go. Magnitude is 1, length is 1. And if the magnitude is 0, that's true only if, actually, if and only if, you're talking about the 0 vector. The 0 vector just means nothing. It doesn't go anywhere. It's the form of 0 in vector land, right? Don't when you multiply shit by 0, don't you get 0? Kind of the same game when we start messing with a 0 vector. We need something that's called 0. Whatever. Let that shit go. Going back into yellow. When you get a length of 1, we call it the unit vector, just like the unit circle. It's like that shit might be tied together. So component form, let's do one quick example. I don't know. let's do it like this. Let's say we got some 0.1 and it's a 2 comma negative 1, and then we got some 0.2, and this one is a negative 3 comma 3. Real shitty little graph here. Boom, there's our one in blue, 2 comma negative 1. Right, and then we got negative 3 comma 3, so I gotta go back 1, 2, 3. Let's go up 1, 2, 3, and then we gotta put some freaking point in here, huh? So negative 3 comma 3, and then we can make some sort of vector that's gonna combine the two of them together. I don't know, let's make it. I've been liking pink lately. Let's go pink. So we got some sort of arrow going this direction. So isn't that going like in the negative x direction, and it's going in the positive y direction? All right, that's the direction we're going from 0.1 to 0.2, and we want to try and find some sort of freaking vector from it. Well, I think the vector is merely going to be, that's just the difference in your x values. I don't want to freaking write this shit in. The x values are going to get negative, correct? So you think you're going to get 2 minus negative 3, or maybe is it going to be negative 3 minus 2? It's the difference between. Do it with me. How far is it to go back to 0 from 2? It's 2 freaking units. Now how far do you have to go to negative 3? 3 more units. And aren't you going negative? What's 3 plus 2? Negative freaking 5, because that's the difference. Now how far is it going up? How far is it from negative 1 to go up to freaking 3? From 1 up to 3. Negative 1 to 3. How far is it? It's 4. So 3 minus negative 1? Shit, that equals 4. I don't like doing the algebra of it. You can follow that formula and do your subtractions if you want to and write this in as negative 3 minus 2, comma 3 minus negative 1, and you still get the same thing. I want you to use a little bit of frickin' logic. So there it is. Now let's figure out how long is this vector. And that's our magnitude. Where once we have our vector, we just square up our components. They keep calling this, what do they keep calling this? V1 and V2. Keep calling this from your text, V1 and V2. I don't know, call it A and B, call it whatever frick you want, but make sure you know what you're doing. So we're going to take our negative 5, we're going to square it up. We're going to take our 4, we'll square that up. And we're going to get, what, 25 plus 16? And I believe that's root 41. So let's leave that thing alone. I think it's sufficient. So hey, there's our first foray, or our first jump, or whatever frickin' word, into our component vectors. At first, shit, you already had to do an assignment. So there we go. There's the component form of the vector. Next time we come back, we're going to talk about how we add them and how we do multiplication with them. But you already know. See you soon.